All right, this video is for my Calculus 1 class. This is number 2 on our inflection points and curve sketching lab. So here I have another polynomial, f of x equals 2x to the 6th minus 6x to the 4th. And I did a little sketch over here. I kind of set everything up. I did my sketch, and I have my f prime and f double prime bar done. I also have set up my critical points, my inflection points, my y-intercept, my horizontal asymptote, and my vertical asymptote. So the first thing is, first of all, I can't spell none. I was able to put none for horizontal asymptote and vertical asymptote because this is a polynomial. And remember, the horizontal asymptote, we had 3 rules that we had, and we will have some like that. And the vertical asymptote is when we took the denominator, sorry about that, and put it equal to 0. In this case, there is none because it's a polynomial. It's not a rational function, so I can say none. And my y-intercept, all you have to do is look at the calculator and plug a 0 in there, and you'd see that if I threw a 0 in the x spot, it'd be 0, 0. So I kind of set that all up. I also graphed it on my graphing calculator. This is what it looks like. This is much nicer looking than what I did, but it's here, and I see that it's coming down here, and it looks like it's a little flat here, and it's coming down as well. All right, so there we have it. Let's get started. So the first thing I'm going to do after I set it all up and do that kind of stuff, and you can stop this video at any time to make sure that you have, is we're going to do the first derivative, which is for our critical points. So I'm going to do f prime of x. This is all the power rule because I just want you to get used to this. So it's 12x to the 5th minus 24x cubed equals 0. And then I'm going to factor, take out the 12x cubed. When I do that, I get an x squared minus 2 equals 0. All right, now I'm going to put each piece of this equal to 0. So I have 12x cubed equals 0, x equals 0 after I divide by 12 and raise it to the 1/3 power. I have x squared minus 2 equals 0, x squared equals 2, x is plus or minus radical 2. Excuse me. So let's kind of set this up. So my critical points, those are my x values. So my critical points are going to be 0 something. And when I plug 0, 0 in, we already found that before with the y-intercept. And then I'm going to have positive radical 2. When I plug that in and look at my table, I have an 8. And a negative radical 2, I also have an 8. So those are my critical points. I'm going to come up here and put them on my graph. So here's 0. Here's, let me undo that because my graph's a little over far. So this is negative radical 2, and right here is positive radical 2. Okay, so I've kind of set up my number line here, my f prime bar. Now, again, you can actually graph your derivative, so I'm just going to box this in right here. If you look at this, and I'm going to plug in numbers to the left of negative radical 2, between that, here's a 0 in here, and I have positive radical 2. So if I go to the left of negative radical 2, let's pick, you can pick anything, negative 7. When I square a negative, it's going to be positive minus 2. So this is going to be positive. This is a cubic. This is negative. So this is going to be negative here. Okay. In between negative radical 2 and 0, you can pick a number very close to 0, or like I did negative, I think 0.1. When I do this, this turns positive, and this is negative. So, excuse me, this is negative, excuse me, when I square this, and this is a negative times a negative. So it becomes positive here. And I did the same, like a positive 0.1. When I plugged that in, I got negative values. And then when I went a larger number, I got positive values. Now, here is what I want to tell you. I have some people who just kind of put that in because that's what I said. You can graph this, what's in the blue box here, and just look at what the signs of your slopes are in between there. So this tells me my original function is decreasing. I don't know why I started writing increasing. Is decreasing here, increasing here, decreasing here, and increasing here. And that's what it looks like in my graph. It's decreasing, increasing, decreasing, and increasing. Now we're going to take the second derivative, f double prime of x. And so when I do that, I'm going to get 60 x to the 4th minus 72 x squared. Now I'm going to place that equal to 0. And when I do that, I'm going to factor out a 12x squared. And when I do, I get 5x squared minus 6 equals 0. Put each piece equal to 0, so I have 12x squared equals 0. X is going to be 0 because I'm going to divide by 12 and take the square root. I have 5x squared minus 6 equals 0. 5x squared equals 6. X squared equals 6 over 5. X is going to be positive or negative radical 6/5. Remember the positive and negative, okay? So again, I have 3 inflection points. My inflection points are going to be 0, 0, positive radical 6/5. And when I put that in my calculator, I get a beautiful number, negative 5.184. And when I put a negative radical 6/5 in there, I get the same, negative 5.184. So I have my 3 inflection points. The last thing I got to make sure that I do is I'm looking for my maxes and mins. So we're going to go back to the critical points. And I have to put my inflection points here in my bar. So let's do the maxes and mins first. So here I'm going down, then up. So this is a local min. My slopes are going up, then down. So this is a local max. Then it's going down and up. So this is a min. So it's kind of cool, actually. You have a local max here at 0, 0. And then here I have 2 local mins, or local minimums, if you will. Okay? So we did that part. Now let's put our inflection points in here. So this is a 0. And then I have here for the 6/5. So that's going to be in here. Negative radical 6/5. And then positive radical 6/5 goes here. And then when I put the numbers in, and I used this one, again, I'm just showing you this, you can put it in your calculator. It makes it easier, actually. When I do, I get positives here, which is concave up. And here I get negatives here and negatives here. So in the center here, it's concave down. And up here, it's concave up again. So now, well, that doesn't look good. So now I've done every little piece, and I want to model to you how exactly I want you to do these in class. So there, everything I've done matches my graph. So I hope this helps.